And welcome to tomorrow. Let's go around the room really quick and see what we're going to be talking about today. Jared?
Sure, all these worlds are yours except Europa. Attempt no landing there.
That's intriguing.
What could it be?
Oh, Mars is poisoned with perchlorates, and now we know why.
Awesome.
I don't think I can say that sentence. Space Mike?
SpaceX is planning some upgrades to their Falcon 9, and I can't wait to talk about it.
Block 6, block 5.5.
Maybe,
something
well,
like
not
that.
quite. We'll figure it out.
Sounds like an awesome show. Stay tuned. Tomorrow, Orbit 11.44 starts right now.
Good morning. How's everything up in the sky? Stand by.
I think we should get actually we should do quick introductions because we don't really do that enough. So I'm Benjamin Higginbotham, and creator of Tomorrow. I'm going to head it over to Space Mike. You are a rocket specialist. You're going to be doing our launch minute, which is always fun. You've got a couple of launches this week, so I'll hand the baton off to you and take it away.
Well, before I do that, did you want to introduce everybody?
No, we'll do it.
We'll do it individually.
We're going to do it one at a time, Mike.
This week was awesome because we had 2 launches of my favorite rocket, the Soyuz rocket. So let's jump right into it. The first launch that we had was a Soyuz 2.1B with the Fregat M upper stage, and this launched on Saturday, November 3rd at 2017 Coordinated Universal Time from the Plumes Cosmic Drome. And on board was a GLONASS M, specifically 757, also known as Cosmos 2529. This is one of Russia's radio navigation satellites, similar to the United States' GPS satellites or China's Beidou navigation satellites. And with this, it's going to be part of their second generation, and there's only a few more left. They should only have 3 more of their second generation GLONASS satellites before they move on to a more advanced system. But in any case, everything seems to have gone well from the launch. We only got to see a little bit of the liftoff because of the nature of the military launch site there. But we apparently everything was successful, and the GLONASS M was placed into its proper orbit. So this particular Soyuz launch was conducted successfully. And for the other Soyuz launch that we had this week, this was a Soyuz ST-B rocket with also a Fregat M upper stage. And this launched on November 7th at 0:47 Coordinated Universal Time from the Kourou Launch Center in French Guiana. And with this particular launch, the Soyuz ST-B is basically the same as the Soyuz 2-1B, but it has different avionics systems that are specifically for the French Guiana Space Center, there at the Kourou Space Center. And on board was the MetOp-C satellite. This is the third of 3 satellites that are a weather satellite, an advanced weather satellite for the European Space Agency. And with this, they are able to reduce the amount of inaccurate weather data by about 25%. So this particular mission is not only was able to reach its successful orbit, but once the satellite is online with the other 2 satellites that are already in orbit, it'll help weather data even more worldwide. So congratulations to Russia for 2 successful Soyuz launches. That was so awesome.
Well done, Hologram. And for those who couldn't see, because you can't see his computer screen, he actually had to do that kind of like on the fly and from memory. So that's really super ultra impressive because his notes didn't make it into the rundown.
Yeah,
so
I
he's
don't
just
know
sitting
what
there looking
happened
at
there.
he's looking at Wiki like, here's the time and date, and I'll just do the rest from memory. So that's really quite impressive, Mike. Really well done. Yeah,
Thank
exactly.
you.
All right.
Thank you very much. Oh man.
So I don't know if you got to see it, but I updated the orbital launches graphic, and I've added Earth in the bottom now.
Earth in the bottom.
So
There we go.
we have the total.
That's good for our total.
It has a total tally for the entire planet, and I am super duper excited to be able to add something like Moon or Mars.
Oh,
Isn't that going to be awesome? That's going to be a real thing.
That's gonna be a real
not just
thing
within our
someday.
lifetime, but I think within like the next 10 years. Like there was a
Oh my
launch
gosh.
from Mars
I'll
that
take a
occurred
dollar
today.
bet Earth is going to win.
Not taking that bet. Not taking that bet. All right, here's a quick update on the orbital launches.
Oh man, so China had 32 launches, 31 of which were successful. The
You're winning.
United States has had 27 successful launches. Russia has had 14 launch attempts with 13 of them successful. Japan and Europe are both tied at 6 launches, and then India is still at 4, although hopefully they'll be having another launch later on this month. Oh man, so we've had 86 successful launches this year, 89 launch attempts, and I'm just, things are getting so crazy. I mean, I know we've had years that have had more launches than that, but just...
We have?
I think so. Well, before our time, long before our time. Like in the 70s, there's been like more than 100 launches in one year.
I'm like, this doesn't feel right. Yeah,
long before we were reporting about this stuff. So.
I'm sure there were lots of asterisks next to those launches. Right?
Yeah.
So for those who don't know, on that orbital update, there's an asterisk for every partial failure or launch failure.
Yeah.
So you can see a few on there.
Yeah, absolutely. But I mean, it was just exciting to me to see both of these Soyuz launches. And whatever, they inspected all the different Soyuz rockets after the Soyuz FG failed with crew on board. And so they've been able to clear these particular launches. I mean, we already had one, what was that, last week or the week before when we had another Soyuz 2 launch?
I think it was last week.
We've had 3.
There have been just
now.
a ton of launches since the anomaly. Yeah.
3 Soyuz launches since the anomaly. And the next FG launch is hopefully going to be this month with the Progress spacecraft, and then if everything goes well, they'll be cleared for launch on December 3rd with the next crew to go up to the International Space Station. But yeah, I was really excited to see also the MetOp-C satellite as well. But there's a comment that we threw in here that I figured we'd address.
Yeah, this is all getting tricky. This is from Jazz Throughout, who says, I'd like to enable ESA flights as Europe rather than European Union, since ESA also has non-European Union members such as Switzerland and Norway. Switzerland specifically manufactures the Ariane 5 payload variants, besides providing funding. So yeah, we did make that change. You'll notice it keeps updating. Like we're struggling with what goes where. Like the Rocket Lab thing is a thing. Like where does that go? And there's a ton of debate. Oh yeah, like there's just tons of debate. And the thing is, everyone's right is the hard part.
Yeah.
Right? No one's wrong in their debate. Like. Anyhow, Rocket Lab's one thing, and then like for that last launch, the Soyuz launch, that was a Russian shuttle that launched from a French territory in South America with a European payload. So what flag do I put on that? Like Earth, yeah, right,
Frankly, Earth,
Yeah, I mean, just that blue
starts
flag
getting
with
confusing.
Actually, maybe that's a good point. Maybe we're at a point where we need to stop looking at these as what countries had what launches.
Well, dude, that's why I'm reporting on all of these rocket launches in the first place. I'm not looking at this from a national standpoint. I'm looking at, here's all of the worldwide rocket launches, and I'm getting excited that for everyone. But just classifying it for who launched what for that, just for statistics purposes. So I mean, I want to give the Electron launches to New Zealand as well. But I mean, specifically for this, I mean. Ariane Space is a customer. They're buying the Soyuz rocket.
Sure.
A team of Russian engineers are coming out to oversee the launch every time that they launch from there. And if anything happens during the launch, Russia is responsible for the insurance policy. So
sure. I want to give
Russia.
So back to Electron. I want to give that to the U.S. simply because I want to win our bet. For those who don't know, we have a $1 bet. As to who will launch more this year, China or the United States, and he's winning by I think 5 right now. But Electron's about to launch, Falcon's about to launch.
2 this month, maybe.
Yeah. So and that I think there's still a chance based on the calendar that I could win, but it's looking unlikely. I think China is going to be the worldwide leader again. It's looking very, very unlikely.
Okay, well, for the first time. Because normally, for
last
years,
year,
at least as long as I've been paying attention to it closely, last year I thought that it was the United States that had the most.
I thought it was China.
Because for the longest time, it's been either the United States or Russia.
More
so Russia.
I'm like 80% sure it was China last year. I could be wrong. If only there was an internet
since I'm in
the
here,
studio.
let me look at last year real quick.
All right.
Now I just have to satisfy that curiosity.
All right, you look that up, and you know what we'll do? We've got 2 launch calendar breaks this week because we've got just so you know.
Yeah, United States last year had 30 launches. Russia had 28. China 18. That's the way it's been for a while. It's usually like Russia, United States first or second, and then China in a close third, and then everyone else.
All right, cool. Well done. All right, so and you've got a boatload of launches coming up next week, just so you know. So be prepared for potentially our first 5-minute launch minute.
It's going to be crazy.
Yeah.
It's going to be great.
Launch minutes.
Hopefully all of those rockets go off.
Well, I mean, successfully.
Successfully. Yes. Hopefully all of those
Lighting the
rockets launch
engine
and
is-
place their orbits, place their payloads into orbit.
Yeah, we want a successful orbit. All right, let's toss
Anyway.
this over to Jared. Jared, what? That
Why can't we land on Europa?
That was very
in the
cryptic.
cold, yeah,
What's
in the
going
cold
on?
open. That was from 2010.
Yeah, 2010.
The far
Both-
inferior to 2001.
Well, it was also in the book as well for those of us who read things. So, you know.
wow, all angry
just,
over
just
there.
Just gonna say this
You mean
because
like paper books? Not
yeah,
on the
you know,
internet?
you look at paper and you hallucinate things.
I'm a sent
So-
iPad because I don't read.
Yeah. Anyways, we're going to Europa because Europa is obviously one of those places that we really want to study because it's intriguing to us because we think that there's a subsurface ocean there, and there's got to be something that is melting the ice to make a subsurface ocean. So like some kind of hydrothermal or Europathermal activity happening there.
Europathermal, I love it.
And what's cool is that here on Earth, everywhere where there's a source of energy and water, you find life. So that means that there's a very high possibility that there could be life on Europa. And one of the ways that we want to figure out where to land something in order to have a better chance of figuring this out is that we want to study the surface temperatures of Europa. So just to give you an idea of the surface temperatures of Europa, right around the equator of Europa, it's about minus 160 Celsius. And then in the poles, it's about minus 220 Celsius. So it's a little cold. Now, they've been using the Atacama Large Millimeter Submillimeter Array, and that is a radio interferometer. So basically taking these radio telescopes, combining them together so that it's like one big, gigantic radio telescope. They have 66 of them, so there's quite a lot to combine together. And they've been using that to actually measure Europa's surface temperatures. And they took a global map of Europa's surface temperatures, and they ended up comparing it to the data that Galileo took, which was a NASA orbiter that was at Jupiter from 1995 to 2003. And during a couple close passes of Europa, its magnetometer, which measures magnetic fields, noticed fluctuations in the same area that Hubble data has hinted that there might be water plumes coming out of. And that was something that wasn't seen in the data, Galileo's data originally. That was something that they went back, re-looked at Galileo's data with the better data processing that we have now in 2018 and realized, oh, there's like hints that there's these water plumes potentially on coming out of Europa. So if you know where those surface temperatures are at, you can figure out where the plumes are at very accurately. And then you can figure out maybe that's an area where the ice is thin, so you could drill through less, or maybe there might be spots where that potential ocean comes up to it, because we actually don't like have official confirmation of an ocean at Europa. There's these two models right now. One has a crust of ice with an ocean, which is kind of what we're hoping for, because that gives you super strong possibility of life occurring. But there's also another one that says that it's a crust of ice with convecting ice below it, which would be a little difficult for life to survive in, but not entirely impossible for that to occur. So ALMA, the radio interferometer, actually looked at the temperature variation and used that reanalysis with the Galileo data, and it did not line up with what we were expecting. It is basically not much of a temperature variation on the surface of Europa. There's no like real hotspots on this anywhere on the surface of Europa, and that contrasts with the moon of Saturn, Enceladus, where we know that there's liquid water geysers at its south pole, and using Cassini, they actually basically saw very hot spots, 50 degrees Celsius hotter than the South Pole of Enceladus, where these plumes were coming out at.
Still very cold hot spots, though.
Yes, still very cold. Actually, colder than the poles of Europa at those hot spots.
Oh,
wow. So, because it's further out. So this is very interesting, because this means that these plumes on Europa, they could be radically different from the plumes that are on Enceladus. The plumes may be seasonal on Europa. They may happen at a certain point in Europa's orbit around Jupiter, where Jupiter's gravity is squeezing and compressing and pulling apart Europa. The plumes may not actually exist. They may just be sort of phantom data that ends up popping in. And also, another possibility our current instruments, they may not actually be sensitive enough for us to look at that. We may have to have instruments on board of Europa Clipper in order to answer that, which is NASA's mission they're working with at the Jet Propulsion Laboratory to get that going in the 2020es.
I have a dumb question, Jared.
Sure.
It was a magnetometer. Magnets.
Yeah.
Yeah.
Right.
How does it work?
Yeah, right. Yeah, kind of, right?
Free energy? I don't know.
But how is that detecting water, I guess?
Well, water, especially salty water, can actually change the strength of your magnetic field.
Oh, okay.
So that you can actually detect.
So
its
if it was water,
changes.
it would have to be salty water, or just any water can do that?
It's much more prevalent with salty water, but you could still also get it with water too.
And we were
So-
only detecting that on Galileo because it's the only thing that would be close enough. Like we're not trying to do that here on Earth.
Yeah,
using-
in order to
Juno's
measure.
not taking these measurements. Right?
Yeah, you can't measure Europa's magnetic field from here on Earth. You actually have to have a magnetometer there at Europa in order to measure that.
So then, how are we measuring it here on Earth? Because you said you had there was a radio array, but like how are they determining that these plumes are actually like what's leading them to believe that the plumes exist at all?
So what happened is that with the Hubble observations, they were looking at the light that was bouncing off of Jupiter that went through the plumes that were coming, or the plumes that were coming out of Europa. So they were doing something that's called spectroscopy, which is basically when you break down light and you take a look at the different wavelengths of light. And in those wavelengths of light, there will be black lines. And that's where a specific element or a chemical or a molecule absorbs that specific wavelength. And when they were looking at it, they pulled out the wavelengths that we would expect to find from Jupiter. And when they just basically looked at the light that would be filtering through the plumes from Europa, very strong indications of water vapor was there in that light, which would indicate to us that there's a plume expending itself out.
So lines over hydrogen and oxygen kind of thing?
Yeah, exactly, in that area. So that's how they did it. So they actually used light from Jupiter going through the plumes in order to work with that. But there's now sort of this toss-up as to whether that's an actual thing or not, because you kind of have to have, we would expect at least to have these hot spots on Europa where the plumes are coming out at, but they didn't find any. So yeah, it's really weird.
Makes me wonder if either like that was like a really rare thing, like maybe like there was some sort of impact from like a meteor or something like that caused that plume. But I've always imagined that if there is life inside of the oceans of Europa, that it would be really similar to the life that we see in the deep, dark oceans in the aphotic zone of our oceans, where just crazy stuff out of nightmares.
Yeah.
But now I'm thinking like, was this a space
Crazy
whale?
stuff out of nightmares. That's what was waiting for us on
Yeah, it was a
Europa.
fish.
Yep.
Yep.
Yeah, and you know,
At the same time, I would be so excited if we put down something that like melted through the ice and poked the camera through to take a look and was immediately eaten. That would be the best. That would be the best.
confirmed.
Yeah,
Sure.
There's life on Europa. Here's the video.
Europa is our stay away, right? That was the
exactly. And you know that ocean's really deep too. If it is a liquid water ocean there, it's literally like over 100 kilometers deep. So if you want to go down to where the Europa thermic vents would be at, you got to have a heck of a pressure vessel in order to pull that off. Because I mean, our oceans here on Earth are they're like what, 12 kilometers deep at the deepest in the Marianas Trench. So yeah, that'd be incredibly difficult. One of the ideas that they think with life on Europa is that you don't actually deploy a probe all the way down to the bottom of the ocean. You deploy it at the ice-water boundary because you should be able to.
Correct, yeah.
That's a great area where great chemistry can actually occur
And
for
maybe
life
the ice
to occur.
sheets are like rubbing against each other like tectonic plates. And
Yeah.
maybe that's what's causing plumes.
Yeah, and also at JPL, they're not actually studying like a submarine to go down. They're actually studying these positively buoyant rovers. So basically deploy this thing that floats onto the ice
They're
and then
studying-
drives around on the bottom of the ice.
Jared, they're studying PBR.
Like a
Yes.
bumper car.
So, some of us, I'm sure, on this up here are familiar with that. Some more than others. So,
Oh man. Anything from the chat room?
So, I mean, a little bit. So there's the question about, so if the plumes, so Peter Quinn asked early on, but then you kind of answered it anyway, if the plumes were water, or warmer, sorry.
we
And
would
then,
expect them to be warmer.
yeah,
So,
yeah.
being relatively warmer. I mean, this is still not something that you're going to want to like jump out of your spacecraft and take a shower in because it's still going to be really cold. But you know, we would expect at least some kind of signature of a hotspot to be there.
Right. And then Frida asked, any update on a mission to Europa to investigate?
Well, Europa Clipper is pushing ahead, as far as I know, but there's a lot of things that are sort of variable with that. Like, they want to launch Europa Clipper on the Space Launch System, so that way it doesn't have to do a 7-year gravitational assist journey to Jupiter. They just want a literally 24-month direct ascent,
Right.
just a straight shot to Jupiter. But as far as I know, it's full speed ahead at JPL with Europa Clipper. So.
Smokey Durg says you were talking about 12 kilometers and wants to know how deep that is in Stoges.
That would be a little bit of a difficult conversion to make. So,
Yeah.
yeah.
No, I mean, that's pretty much it. Apparently, at some point, I removed Ben Credible from the chat room, but I don't know how or why, and I didn't touch anything. So, good luck with that.
Have fun.
Okay.
Yeah,
Cool.
that's all I got.
Sweet. All right.
Yeah.
Okay.
Turning over to Sarah. Yeah.
All
Yeah.
right.
Exactly. So you had a mouthful in the cold open.
I did indeed. Okay, so when Phoenix lander landed on Mars in 2008, it discovered perchlorates in the soil. And perchlorates are toxic to most life on Earth. But there are a couple of, so NASA was really excited about that because there are,
This could
we
kill
killed
us!
perchlorates! Yes!
Sweet. We can't go to there.
Right? While it is toxic to most life on Earth, there are several forms of life, several microbes that can use perchlorates as their energy source. They don't need the sun. They don't need Marsal-thermal energy.
I think it might be aerothermal, actually.
Aerothermal?
Because
Airy-
Aries.
airy-
Yeah,
aerothermal?
aerothermal. So,
I like Marsothermal.
yeah, that's cool too. So I'll take it.
Yes,
So,
English.
Should should this episode be hashtag Marsothermal?
Yeah.
yeah, something like that. So,
Words and stuff.
words and things.
So these microbes can use perchlorates for their energy. They break the they break the O2 off into, or I should say, they break the O4 off into 2 O2 molecules, and that gives them their energy. And then they're just left with a totally safe chlorine. It's fine, right? So yay energy, yay for life.
Salts.
Thing is, well, we knew how high the density of perchlorate is on Mars' soil. We just didn't understand how it got there. Why is Mars so toxic to most life on Earth? Well, we were thinking, well, maybe it's the same way as we would expect here on Earth. The photochemical reaction with the soil and the UV and the sunlight makes perchlorates. It just does that here on Earth. It does that there on Mars as well. Thing is, Mars has 10 million times as much perchlorate as we would expect from that interaction.
Whoa.
Right. That's a huge difference. We need to figure out where that's coming from. So another way that perchlorates can be created here on Earth is lightning strikes. The energy release in that moment does create this multiple chemical family called perchlorates.
Are there lightning stores on Mars?
Nope. Unless
There's
you're watching
not.
The Martian. No. So Mars' atmosphere is way too thin. It has 0.6% of Earth's surface pressure. That's not enough to build up the static electric energy that we would need for a lightning strike.
Even the crazy dust storms there are just a light breeze here.
Right. But it is from the dust storms. There is enough electrostatic energy built up in the dust storms by having the particulate matter in the air. There is just enough to create this level of perchlorate
Whoa.
in the surface of Mars.
Wow.
And so, and this whole process has been going on for all this
Millions.
time, not just in like the
Millions of years, yeah.
early Martian lifespan, but this entire time it's been building up and could build to even higher levels.
Right.
So how is that going to fare for humans landing on Mars? This seems like this would be bad for us.
Right. So that is one of the things that means we would have to be able to filter it out of our water. If we do land at, say, the polar cap, it's going to have perchlorate dust on it, and because those salts, they just get moved with the wind as well. So any of the water that we mine there will have to be able to filter the perchlorates out.
Yeah.
But good thing for us, perchlorates are a great rocket fuel. So
Yay!
so
We can get home.
yeah, but it does mean that it's going to be a toxin for anyone visiting there, and also one of the things that they found, I mean, Martian soil already has heavy minerals, heavy metals as well in it. So when you're growing, when our future colonies are growing food in Martian soil,
Best sentence of all time.
right?
Yep.
We're probably not going to want to eat potatoes. We're going to want to eat tomatoes. So we don't want the root vegetables. We want the things that grow above the soil. We did the NASA scientists did some studies on growing vegetables in Martian analog soil. And the root vegetables, the heavy metals and the perchlorates and all that garbage was damaging to the root vegetables. It got to levels that would be toxic to humans. But when you start eating the beans and the tomatoes and the things that grow on stalks above the ground, you start getting into levels that are okay for human consumption.
Can we get
Okay, make sure that it's not completely.
That is, yes.
It's okay,
Okay.
though.
Right.
It won't kill you at first.
Right.
Can we get rid of it from the soil? Like, can we?
See, this is why I think that we should be contaminating the planet on purpose. Let's send those microbes that can filter this stuff,
Right?
and then all we need to do is figure out what to do with the chlorine afterwards.
Not a bad
So-
thought that those microbes are, I don't know the role that they play in Earth life, so I don't know that we would want a whole colony of surface life of those.
Just a patch, see what
Microbes?
happens. Yeah.
So what you're saying is that this study has shown that Mark Watney would have died very quickly.
Yeah.
Ah, gotcha.
Well, before
Well-
he ran out of
So-
ketchup.
Yes.
Yeah. Yeah.
Yeah.
Oh, spoilers! I'm sorry. I'm sorry. Spoilers.
soon.
Sorry, guys.
So
Sorry
wait,
about
that time lapse of his body deteriorating, that was actually like a couple days? Not years?
I don't think heavy metals work quite that fast even here on Earth, but
I don't know, they messed
It
up my
would've been-
brain.
This is like, but I mean, all of
Oh,
this.
chemicals, not music.
All
Yeah.
of this is legit
Yeah.
bad for us, though, right? I mean, if we're
It
if
is.
we're going to be on Mars, it seems like. Also, you said what was the pressure of Mars again? 0.6.
yes, 0.6% Earth surface pressure.
So pretty. I would
like
say closer
100
to a
pascals?
vacuum than it is to
Basically,
Earth.
yeah.
So when we're talking about terraforming Mars, we've got to bring the pressure up
Yeah.
by most like 99.4%. Although
And
I
we have
suppose
to
we don't need
figure
to
out
bring it
how
all the way up.
we have to
Yeah.
figure out a way for it to stay there too. Otherwise, it's just going to
Yeah, there's no
Yeah.
magnetosphere to like.
Right.
Well, there's no anything, right?
Yes.
There's no
Yeah.
spinning. There's no any of the.
Well, I mean-
We don't know about the core. So InSight is actually InSight that's gonna
The core.
the core.
We need to drill to the
Right.
center of Mars and restart the core. It's the core 2 out in theaters next
Oh,
year.
the pain. But so we've got a couple options for that. I mean, first, we don't know about Mars's core yet. We are pretty sure that it does have at least a molten core. It's that core is not spinning. And so the NASA lander that's going to get there on November 26th.
The
Yes.
InSight
Yes,
lander?
InSight lander. It's a seismometer. And so we're going to have a much better idea of what the interior structure of Mars is like, so we'll better understand why it lost its magnetic field. And so then we might have an idea of what we need to do to protect Mars's atmosphere in the future. NASA has an idea of putting a dipole in space in a solar orbit, just in a Lagrange point, just in front of Mars, between Mars and the Sun, that would create a magnetic shield, basically, just like literally holding Captain America's shield in front of Mars and having the solar wind deflected.
It needs to look like Captain America's shield.
really does.
That would be
Like-
amazing. That would be also
Right? We
like
could
it
just
needs to
have
have a
it-
camera on board too that shows this
Yeah.
live view
I
of
gotta
Captain
say-
America's shield holding the solar radiation at bay. Oh yes.
You guys are going to have to make a deal with Wakanda to get all that vibranium. I mean, that's going to take
So
that's
we
gonna
don't-
be really difficult.
We don't need the physical one. We could have the energy that Stark created for him. So we could, within the energy
okay.
field, we could draw the star and then the rings.
Okay. Gotcha.
I have not thought about this in depth.
Oh man. Well, I mean, Elon has joked, maybe not joked about nuking the poles and restarting the cores that way.
Oh, yeah,
Yeah,
we-
but nuking the poles doesn't
Nuking
work,
the
right?
poles,
Yeah.
no.
That doesn't
That's-
work.
No,
Okay.
that doesn't. Because
and you'd radiate all that water.
No,
so
that's not how that works.
No.
all that
No.
ice.
So, yeah, physics says no.
Yeah, physics says no.
Okay, hashtag physics says no. That might be the
Yes.
new.
Says no.
the
We
new
are going to
hash.
have to science the
Yeah.
shit out of this, but physics says no.
Anything from the chat room?
Yeah, quite a bit.
Whoa!
Oh,
Everyone wants to talk about toxic
Well,
things.
Yeah, apparently.
Yeah, so Seki wants to know how many active rovers are on Mars right now.
Active?
Active. Officially confirmed that we are communicating with rovers 1. Curiosity is still going because we have not heard back from Opportunity yet, but we're still trying.
All right.
And
Michael,
there are no more landers that are active at all, right?
Landers? No.
No.
Everyone knowing,
nothing.
for those who, like, rovers literally move, landers go bloop, and they stay there. They can't move. They're stuck there.
Yeah. We have lots and lots of orbiters, and that's
Yeah,
how
that are
we
still
are
active,
communicating. Yeah.
Michael Farrell from YouTube says, with so much O oxygen tied up in the Martian soil, is a possible source for atmosphere?
Oh. Toxic atmosphere? Like, can we release all the toxins into the heavy
Release
metal
the
atmosphere
hounds.
somehow? Yeah.
Well, if we could release that O2, that'd be great. But Earth's atmosphere is about 21% oxygen. The rest is nitrogen, and I don't know that we've got a source for replenishing that.
Can we bring our own?
That would be a plant thing.
Yeah.
Yeah.
But
Yeah.
plant thing, okay.
And
so
you've also-
next dumb question: soil bad for us, but what about like if we wanted to bring trees and whatnot? Will the trees be able to survive that, or
Like
what's going to
eucalyptus and
happen?
Bamboo and stuff.
Right, that I don't know. Some fast-living, fast-dying plant matter. That I don't
produce
know.
A lot of oxygen.
Right. I mean, if we would have, I would imagine that the heavy metals wouldn't have quite the same effect on plants as it would on us.
They would have
but-
gold brick leaves then. That's how that works, by the way. Just leaves made of gold.
I'm for it.
That's what that means.
Just picturing like a
May or
kelp
may
forest
not
of
glow in the
unobtainium now.
Another big problem is that you've got to figure is that when you are building up the atmosphere of Mars, you've also got to build it up faster than the sun's solar wind is stripping
Right.
it away.
So
Yeah.
first, the
exactly.
dipole.
Yes.
So lots of
Then-
challenges.
If you don't go the dipole / Captain America / vibranium shield
Right.
route, we've
Yeah.
got to do. Yeah.
I've always wondered too if we could crash asteroids and comets into Mars on purpose.
Right,
Use
the
all sorts
redirect.
of capture missions and stuff like that.
Well, so Jazz Thoreau says, I'm a geologist. I can tell you that the reaction to the soil removing O2 is much bigger issue than losing atmosphere to space. And he goes on to say, you can free oxygen from the soil, but the problem is keeping the soil from taking it up quickly again.
Interesting.
Yeah.
Interesting.
Yeah. So it will rebond with stuff.
Yep.
So.
I'll just
Yeah.
take that
Oxygen is
back.
very reactive.
Yeah. Yeah.
Oxygen's like, I want all the electrons.
Right?
So
It's-
what-
it's- but basically, the reason Earth is the way it is plants. Plants bound up all the carbon, and it is because of plants that we have free O2 molecules.
So the answer to Mars is we need to figure out how to get just a boatload of plants there.
Yep.
Way to go, plants.
Yes, we
Plants
love you,
for
plants.
nothing. Plants.
Again, let's
No.
start contaminating the
Come on,
planet.
plants.
Let's start launching missions that have a ton of seed pods in them. Let's just do it.
Hack the planet! All right. Let's take a quick break to show what Space Mike is going to have to deal with next week. Now, before we do that, we wanted to thank our patrons of tomorrow for helping make this show happen. These people have contributed $10 or more to the specific episode. We're trying to do a bunch of cool new things with the show, and every single person contributing to the show helps to make that happen. Space Mike, you were just recently at a conference.
right.
The patrons helping to make this go. Our citizens help pay your way to make that happen, and we'll get some, hopefully some really cool. Did you get some good interviews out of that?
Oh yeah. Well, there's quite a few interviews that I got, but probably my favorite one is I got to sit down with the new CEO of Martian Space Systems.
Ooh.
And we talked about quite a bit of stuff. I'm very excited to share that interview.
Cool. All right. So
Nice.
for information, head over to patreon.com/TMRO. We're going to take a quick break, and when we come back, more space news.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation, this girl's a fascination. And nothing in her way will keep her from her destination. 'Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving. Through the heat, keeps on improving. Yeah, she's fire walking.
And we have acquisition of signal. Haha. Haha. I forgot to say loss of signal before the thing. I'm making it a thing. I'm making it a thing.
Just those little laughs behind it.
Oh, and you know what
It was
else
so
I didn't
good.
do? I was going to, so I introduced Mike, and then I was going to introduce each person as I went to you, and then I promptly didn't do that.
Thanks.
So,
I had a
Thanks for
feeling. That's why I was like, you sure you don't want to go?
yeah,
real
no,
quick?
no. I should. What I should do is introduce people as we go to them.
Okay, well, nobody cares anymore now.
Again, this is Ben, the founder of the show. I'm Space Mike. I love rockets.
Creator of tomorrow. No. So let's.
This is Jared.
We're going to try to do it the way I intended to do it.
This is
Actually, I'm going to move the show order around a little bit. So actually, we're going to start with Jared. And Jared.
Jeez. Okay.
Yeah. Oh yeah. You're up next. You're going
Jeez,
first.
again.
And actually, for those who don't know you, you work up at Griffith Observatory.
Yes.
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 It's doing astronomy. Well, you kind of do the. You help people understand astronomy.
Yeah, basically.
Yeah,
So,
that's-
because scientists not particularly great at talking to people. So not
But Jared
known for
Head,
it. But
amazing.
in my case,
It's the Mohawk. that
it
helps.
is the linear harrow spike.
So what have
yeah.
you got? You've got.
Yeah, so I just want to talk about some fast things because everybody likes fast things, right?
Oh, yeah.
It's just hot, nasty speed is what everybody wants. And speaking of fast
I said
things,
no one ever, but thank you for
Speaking
that.
of
Go
fast
on.
things,
Yeah, no, go. It's totally fine. Just let the man talk.
So, fast stuff happened this week near the sun, which is Parker Solar Probe, which is just like an incredible mission to literally go out and touch the upper atmosphere of the sun. Like, that's, I wouldn't recommend. Yeah, just like that. Here, we'll show it again. Show it again real quick. Yeah, just like that. Just like that. Parker Solar Probe has completed its first perihelion of its first orbit, which basically means this is when it's closest to the sun for this first orbit. Now, this occurred on November 5th. It did it about 24 million kilometers from the center of the sun. So, whoa, that's close. It was very, very close. In fact, it was so close that Parker Solar Probe was moving at 343,000 kilometers an hour. So that's like a lot.
wow.
That's a lot of kilometers per hour.
Whoa.
That is 95 kilometers per second. So, which
a lot
I'd
of
much rather
miles.
move that fast to like get to my vacation places than
what is the
it usually
fastest system
takes.
we have in the solar system? Is
The
that
fa-
it?
the-
Is that-
yes,
That's got to be like.
That is, it has officially, in its first orbit around the sun, which is nowhere near its closest orbit, it has set both the speed record and the distance record for closest to the sun for
Whoa.
a spacecraft that we have set.
How hot is that thing going to get?
So the heat shield, it reached 435 degrees Celsius during this one. So during this
That's
pass.
not even as close as
So-
it's going to get.
No, and yeah, that's a little hot, ain't it? So. I mean,
Yeah.
like 435 degrees Celsius. You're like, if you're cooking burgers, like those are charred at the second. So, yeah.
I was wondering if you were Googling that.
I
to
am.
see-
I'm actually pulling this up right now.
I was trying to take a look at your.
because I couldn't recall. I did not write down in my notes what the hottest
I
for
could
Celsius
see the
was.
look on your face
Yep,
of like,
so
I need
here
to
I go
try
again.
Yep.
So the hottest it'll get during its closest points on its orbit, which will happen around 2024, 2025. The heat shield will get up to about 1,370 degrees Celsius on the side facing the sun. And the interesting thing about that is that the things
For
in,
how long though?
well, I mean, for days at a time. So, I mean, you're getting close to the sun. So
like,
and
and
you're
I
getting
believe-
progressively closer. So, I would imagine as the heat builds, it's not going to be like 2,500. It's not 1,370 degrees Celsius for this entire week. But, you know, it obviously reaches a peak, but it's going to be really dang hot, you know, for a very long time. And I mean, most things don't do well in really dang hot for long periods of time.
So Helga says, "Oh boy, that's hotter than you need in a pottery kiln."
Yes.
No kidding. And
That's
Beth,
the sun for you. So-
BF says melting point of lead is a lot lower at 327 C.
yeah, and if I remember correctly, it's using very similar to the reinforced carbon-carbon that is used on the space shuttle's heat shield.
Yeah.
On
So
there.
one side of it's blazingly hot, and then it
Yes.
just absorbs that. On the other side, you
Yep.
could almost touch it with your hand.
Everything.
Probably
is-
would not recommend that.
No,
So-
it's actually supposed to be about room temperature on the other
Yeah,
side.
I was going to say,
Wow.
in
Well,
the
wait,
shadow.
What's room temperature in space, though?
So in the shadow.
no.
It's a big
room
room.
temperature of Earth.
So in the shadow of the shield on the other side, the instruments will be at about 25 degrees Celsius.
Yeah.
Wow.
So, and they actually confirmed that with this first perihelion that it kept them right at
So
about
is it just
24
like
degrees Celsius.
is it just like the shuttle shields where they're only about like yay thick?
They're about
I'm-
4 inches.
Yeah,
Okay.
so it's much thicker.
Yeah.
So that's
than
about
that.
like
so.
Yeah.
whatever that
Yeah.
comes out to in the metric system because I'm a terrible human
Yeah.
being.
4.
And I think it's that way because I think it's much thicker because it's
15
sustained for much
centimeters?
longer. So, but yeah. So it started data gathering on October 31st. As it started to really get close to the sun. But we're not actually going to be able to get the data back until December because the Parker Solar Probe actually has to sort of move out of magnetic interference from the sun. Before it can actually send the data. Because if it sends the data right now, it's just going to be like completely garbled by that. But here they are at the Johns Hopkins Applied Physics Laboratory getting basically a carrier signal that says, hey guys, I survived. So there you go.
Is that its voice too for the probe?
That is now canon for
Got it.
it.
Yep,
So
yep,
yeah,
yep.
there you go. So yeah, holy moly.
Wow.
We're going fast and we're cooking.
So Marty the Martian says it's hotter than Australian February.
Yeah, that's true.
So for
Hotter
those
than Arizona summer.
Yeah. Yes.
Sheesh.
Well, let's see. The thing is that in the southern atmosphere, or the southern atmosphere,
The
in
southern atmosphere. No, I like that. Yeah.
Yeah, there's the
man.
title for the show.
Yep.
Yeah.
There it goes.
The Mars hashtag Southern Atmosphere.
I hate you all because now I'm so off track.
No, you're fine.
Hemisphere is the word that I want. February is summer.
Right.
Right. So
Yeah.
for those of us in the northern hemisphere, that sounds weird. I apologize for that. Mac then says, Jared, days when one side is always facing the sun. How did days work?
What is the sound of one hand clapping? What color is blue? I don't know.
And then,
So, dumb question, like, why are we doing this? So, yeah, cool. We've got the spacecraft.
Sure.
It's really hot. It's getting sucked into the sun's
Gravitational,
gravitational well.
yeah.
It's going to be moving one unit of absurdly fast.
Oh, yeah.
And then it's going to be moving 2 units absurdly fast.
Yeah.
Why?
Well, we're doing this because the sun is kind of important to Earth, right?
bit, yeah, the
so
day star.
Basically, like almost all of the energy that we use here on Earth comes from the sun. So whether you want to admit it or not, you basically run off of photosynthesis. Through the food web, that's how you survive. So congratulations. You are entirely dependent upon the sun. Also, we are basically like in the firing range of the sun. So, so if the sun pops off a big flare, it has the capability of like destroying electronics
Yeah.
and things like that. It's not going to do like that one Nicolas Cage movie where like fire rolled across the earth and that was it. The earth was cooked. Like that's not how that works.
Is that a real movie?
Yeah,
is
yeah,
now.
I think so. It's like
He heard your idea and he already made it.
so.
It's the sun. Sorry.
Nice.
Sun is going to try the earth.
But yeah, but it's obviously very important, especially the geostationary spacecraft and GPS satellites and other things like that, like things that we kind of depend on in order for civilization to work. So
Famously happened to the telegraph system, right? It electrified the
yeah,
whole
the
system.
Carrington event in the 19th century. Also, another really good one in the 80s in Canada. I can't remember where in Canada it was, but there was a solar storm that literally knocked out the entire power grid.
Ah, jeez.
Right in the middle of winter, too. So I don't think anybody died, but obviously, I would imagine a winter in Canada without power, not exactly.
Oh, no.
Oh, that's very bad. He's going to get really cold, really
yeah.
fast.
Oh, yeah.
So, yeah, so not exactly a good thing. So by getting like deep into the sun's atmosphere, not only are you taking samples like right there, so you could see what happens when these kinds of events occur, you could also look out of the sun's atmosphere. You could see how these events continue out as well. And what's really cool.
So you're looking away from the sun and watching it go past you?
So it has cameras. There's 2 cameras on board, a wide field and a narrow field camera that will actually allow Parker Solar Probe to watch things from the sun that are zipping past it. And what you can do, especially at the points where the Earth, you'll have spacecraft that are in orbit around the Earth, or at Earth-Sun L1, I think, that are looking at the sun. You can actually look you can combine the images that are taken from Earth-Sun L1 with what Parker Solar Probe is taking, and you could generate a 3D model of whatever is going out into the solar system, and you could get a really good idea of how that interacts on its way out. So then you can get much better at predicting space weather and other things like that. So, which is of the utmost importance, especially if you're going to start sending crewed missions on very long duration flights.
Even just to the moon.
Yeah, even to the moon.
Just to the moon. Like
yeah,
if
you're
you
only in the Earth's magnetosphere for maybe a couple days during the orbit. So the rest of the time you're fully exposed. So
yeah.
Wiki, Dutta is what I'm trying to say, wins. And those of you who are wondering, the Nicolas Cage film in question is called Knowing.
Oh my God, I was joking. I did not think it was a real movie.
Yeah.
Oh man.
It's
Everything
knowing.
about that is terrible.
I just remember that it was like a movie where he's like obsessed with numbers, and all these numbers are like proving to be real or something like that.
But I thought it was like a buried signal thing. I thought there was like a
I don't
countdown
know.
to something, wasn't it? I saw
yeah,
that movie and promptly forgot it. But
Oh man.
Yeah.
Oh, that's all ringing. It feels like all of those bad sci-fi movies.
Right.
Yeah.
And it was like numbers buried in a kid's doodle.
Yeah, I think it's that. I think that's
and
actually
in
what
the
it is.
crosswords and
Yeah.
yeah.
Wait, was that movie, or was that the Kiefer Sutherland TV show Numbers? Not Numbers, but the other.
Oh yeah. The other one after 24.
Yeah.
Designated survivor?
No, somebody's gonna know though.
Okay.
Yeah.
Well, obviously we don't know what we're talking about.
Well, we
so-
diverged.
Obviously, sorry.
Yeah.
That's gonna happen.
So there you go.
Interesting. Anything else from the chat room?
Sorry.
You're stuck in the movie still.
I was.
Smoky dirt.
I was.
That is such a good.
Yeah, we're not even going there. No, I mean, not really. Like, no. All of that made sense, and we got onto like a whole lot of other
All right,
stuff.
all right.
No, it's fine.
Let's move on. Let's move over to.
I would have interjected.
Let's move over to Sarah. Let's go back to you. I should add. I'm going to do this live on the air.
man.
So I moved all of your notes into the thing. Are you okay with this story, by the way?
Yeah.
All right, cool.
Yeah.
There was a whole little last minute like time zone thing. So, all right. And
Yeah.
I haven't introduced you. So, Sarah Vincent, you also work at the observatory.
Yes, I do.
And you also educate people on all things happening in our cosmos.
Yes.
Yes, that is your role, is to get people excited and understanding on
Yes.
up at Griffith Observatory.
I do.
Dare I say, one of the premier observatories for
In the world.
The
normal people.
only municipal observatory in the world that I'm aware of. So.
I'm pretty proud
Well,
of
I mean,
it.
you can't normally just go to an observatory, right?
No,
But
in
Griffith-
fact, our benefactor, Griffith J. Griffith, when he went to Mount Wilson, after looking through the telescope, because, money, they wanted to get some money out of him.
For more private observatory.
Yes.
Yeah.
He was like, what's the public think of this? And they're like, we don't let public up here. We're scientists. So that's where he got the idea of having an observatory specifically for the public.
Yeah.
So, and we've been doing it for 83 years now.
It's iconic and beautiful, and if you're ever in the
Yes.
Los Angeles area,
gorgeous.
Absolutely something you need to do.
Yeah, go to
and
it.
you can probably find one of these two
Yeah,
up there.
I'm not hard to miss.
You know you are
So,
not, and if you see them,
big
just
hair,
ask them to show
bright
you around and
colors.
do things.
Yeah, sure.
Yeah,
I'll do
okay.
it.
Cool. All right.
So-
So Sarah, yeah.
Awesome. Okay, so let's see. I'm back on Mars.
Return to Mars.
You're stuck on Mars this week.
Yay!
All right.
So I'll
Don't
be
eat
talking.
the plants.
Hologram from Mars is much better than mine. Jeez.
Second generation technology, Mike.
Right? Yeah. Upgrade. So all right, so this one is about Mars water.
Great. So we start with how you can't grow anything
Right.
in the soils, and now you're going to end with how you can't drink any of the water.
Right,
Yeah.
but this was ancient Martian water, so it was probably way less perchloratey.
Okay.
All right,
faulty.
so this is team from Jackson State University. They used Curiosity's pictures of the surrounding terrain in Gale Crater, and we know the Gale Crater was an eroded. It's a crater that filled with sediment over time, and then it was eroded fairly quickly, leaving that peak in the middle. The sharp peak is not a volcanic peak. It is not an uplift. It is not a
Like it's not like the plates, tectonic.
Yeah, it's not.
You're saying it's an island?
It is an island unto itself.
Wait, what?
Yes, Sharp Peak is a sedimentary erosion artifact. Because sediment in the crater.
All around that.
Yeah,
That's amazing.
and then that fast
Water
moving
that you can't drink, but still water.
right.
Yeah.
Or you
water
could
that's
have
long
back
gone.
then, maybe.
Maybe.
Yeah, but
Yeah.
so it was left behind, and that leaves layers of the sediment exposed. And so, studying the images that Curiosity has taken, this team from Jackson State University, they said, "Whoa, we can determine from the lumps in the ground around Curiosity that the erosion happened really fast. It was fast-moving water that shaped the terrain and left Sharp Peak in its
Whoa.
path."
Wow.
Yeah.
Why are the speed? Like gravity?
So he said that the lead scientist on this said that it was probably an event or an epoch in Mars's evolution, a couple billion years ago, when it had that world ocean that created a situation that was a lot like Earth's Pleistocene era, where we had a frozen northern hemisphere and a melted, warm southern hemisphere that created huge melts that just whipped from the northern hemisphere down to the southern hemisphere, eroding huge swaths in its path. Mars had a similar thing, but just reversed those poles. Southern hemisphere was frozen, northern hemisphere was warm, flooding.
Mass flash flooding.
Mass flash
Yeah.
flooding, and like 10 to 20 meters deep. Yeah.
Wow.
Where'd all the water go?
Oh, the
It's in
sun
space
stole
now.
it.
The sun stole
The
it?
sun stole the atmosphere,
Yeah.
and it stole the water with it.
Man,
I know.
thanks, son.
Right? Parker
left
Solar
behind in
Probe's going to
space
tell us all about
long
the
ago.
how.
Yeah, that's why we said Parker Solar Probe to collect.
Yeah.
So that's what's up.
Wow.
I feel like its voice should be more like a regulator then.
Oh, regular.
Hey,
Solar Probe, I'm doing fine. My senses are good.
hey, how's it going? Good to see you, son. How long's it been? Yeah, maybe that ought to work a bit better.
Does this have any leads for like life that could have existed then? Because if there's water, much
Right.
like we were talking with Enceladus Europa,
Water.
do we think that maybe there was, rudimentary life back then, or do we not really know?
We don't know for sure. So this one is more like if there was life. So this was the period with the world ocean. So if there was going to be life, it would have been then. So if there was life, this is more the environment that they would have been dealing with. So by the way, that lovely that plant, your root system and everything, it's going to get washed away by this.
Oh,
Yeah.
I know.
yeah.
Yeah.
So,
I mean,
but this is actually this might be actually interesting for the Mars 2020 rover when we're picking as we're picking landing sites. One of the sites, Jezero, I want to say.
yeah, Jezero Crater.
Jezero Crater,
which is the leading
Yeah.
site right now,
Yes.
by the way. So
It's actually a tributary system. And
What's that mean?
so it's a river system, ancient river system on Mars, and so all of the plant life that would have been upstream and uprooted by these floods that might have passed through Gale Crater, looks like it did pass through Gale Crater. It would have taken uphill, upriver plant life, if there was any, and washed it down and deposited it in this alluvial fan, this fan of river sediment as it reaches a larger body of water. And so if we land Mars 2020 at Jezero Crater, then we might be looking at the deposits of floods from events like this that created Mount Sharp.
That's pretty cool. Now,
Yeah.
Mars 2020 is basically Curiosity 2.0.
Right.
So it can
Upgrades.
Yeah, upgrades, right?
Yeah.
Okay, yeah.
Will it be able to drill down and look for stuff like that?
Hopefully,
Like-
yeah. So one of the things on Mars 2020, one of the missions is to find evidence, if there is any, of prehistoric life on Earth. We're looking for actual proteins
Yeah.
Yeah.
I do want to say, just to kind of add on,
Yeah.
talking about floods and stuff,
Yeah.
floods are great for chemistry.
Oh, yeah.
So if you get like flood water eroding rocks and other things like that, you
Yes.
get great chemistry in that water, which is super important for life actually occurring. So
Yeah.
Well, okay, so somebody in the chat room off of YouTube, Jan Drake, said, so some of the former Martian water now sits on outer planets as the sun blew it off. Like,
More like in interstellar space, because it
Yeah.
probably got left behind way back then as the sun is orbiting around the galaxy. So who
Yeah.
knows where that water is now? It might have all evaporated.
Well, so-
Maybe it all went
so
to
it's-
Enceladus, and that's what we're seeing.
yeah,
Dum
Yeah.
dum dum.
It was ionized. So the way the sun strips a planet of its water is the radiation heats the water on the surface and it vaporizes it, and then the ion, so it also ionizes it. So it breaks it up into its oxygen and its hydrogen, and then it strips the lighter hydrogen away. And so because it takes the charged particles from the sun, kind of take the charged particles from the surface of the atmosphere and lead them off into space. So it's just atomic cloud out in the outer solar system.
yeah, the oxygen stays there and it actually ends up bonding with the
Right.
carbon already in Mars' atmosphere.
Yeah.
So that's why Mars' atmosphere is basically
Basically.
like 99.5% carbon dioxide.
Yeah.
So yeah, chemistry, yo.
Right?
So
Mic drop.
Microscope drop. Microscope.
So for those who don't know what happened right there, someone likes a little online. What is it, Steve?
Dr. Steve Rule.
Dr. Steve Rule, which is definitely your homework to go look up the world's largest microscope.
wow.
Yeah, I see what happened.
that was amazing. That was great.
I'm about to cry.
I think that's a good one to move on from.
Yeah.
So,
Speaking
By the
of
way,
Mike-
thank you, Everyday Astronaut, and thank you, Mac Malcali, for the tips. We really appreciate it.
What tips?
On YouTube,
We got some
we
money.
got some
Oh,
tips on YouTube.
oh, hey.
Thank you very much. Thank you very much, guys. Thank you.
I've been passively watching. So,
Yeah.
So Space Mike, let's head on over to you. We've been
Yeah.
talking about Mars. Let's talk about the company that's trying to send
Trying to
humans
get to Mars,
Yeah,
yeah.
absolutely. So you said upgrades to Falcon. What
That's
does
right.
that mean?
And there was a couple of SpaceX updates this week I wanted to talk about, but Elon teased over Twitter that there was going to be an update to the mod tech tree of the Falcon 9. And I mean, he said that they were going to be doing basically a miniature version of the big Falcon spaceship, but stage 2 sized on the Falcon 9. And test out all the different reentry technologies that they eventually want to have for the big Falcon spaceship. And some of you may remember several years ago there was animations that SpaceX had put out about ways to not only have the upper stage of the Falcon rocket re-enter the Earth's atmosphere and have solar panels on the side, protective panels on the side. Why can't I speak? Heat shield on one side of the upper stage so it could re-enter the atmosphere, and then it would have landing legs to be able to land propulsively on the surface of the planet. And some of the people that asked Elon Musk follow-up questions, at first asked, when would that possibly be flying? And he said maybe June, and I'm assuming that means June of next year, I hope.
It's Elon time, dude.
Yeah, but still, that's a good that's a good self deadline to put.
That is clever of him to give a month but not a year.
Yeah.
He can be like, oh, I didn't say this year. I didn't say next year.
Yeah, so
I guess you guys extrapolated that yourselves.
Yeah, I never said that. I just said June.
that's why I said I hope that he means 2019, but yeah, it could be anytime. But asking Everyday Astronaut actually asked a follow-up question as to whether or not it would do propulsive landing like this old idea to have propulsive landings of the upper stage. And basically Elon said no, this was just to test the different type of re-entry technologies they want for the big Falcon spaceship. And I'm without having any other details, I mean this is just a teaser from Elon, but I'm guessing that means a lot of the different wings that aren't wings that would be on the big Falcon spaceship.
Wings that aren't wings.
Yeah.
Yeah, I would say they know how to definitely have hypersonic reentry for a stick, but they don't. But you need that experience with a lifting body, if you will, in this
Yeah.
case.
Right,
And
yeah.
that's probably where the knowledge at the moment is lacking. So.
I guess I don't understand how you would view you're referring to stage 1 as a stick, but stage 2 is a lifting body? Like
No, I'm
on
With the
assuming that.
addition of like,
I see
yeah.
what you're saying. With the addition
Yeah.
of that. Okay.
Yeah. So assuming that.
And I mean,
So-
even if they wanted to still do recovery options like that, because I think it would be amazing if we did have a regular Falcon spaceship that the upper stage was connected to like a modified Dragon or something like that, and
Yeah.
all of that came down
That'd be
and
amazing.
landed in the same way that the big Falcon spaceship. But as it stands right now, the upper stage on the Falcon 9 isn't powerful enough to be able to actually land on the surface of Earth because it's vacuum optimized. So
What does that mean? Like, why does that make a difference?
So with the whole thrust to weight ratio and how the nozzle especially on the engine is made is to optimize it to have the most amount of thrust in the vacuum of space as possible. Why that's important is because you don't have any atmosphere to push against. And so without that atmosphere to push against, even though the power of the rocket might be the same if you had a different size nozzle on it as if you were inside the Earth's atmosphere, because it's that giant nozzle that's vacuum optimized, it would not be very efficient. You'd think that more surface area would be able to have give you more resistance or more propulsion inside of the atmosphere, but because of the way that the thrust to weight ratio is calculated, and I don't know how it actually is for the Falcon 9. That amount of thrust when it's in, I guess, its full thrust mode in space for the upper stage would still not be powerful enough for it to have a safe propulsive landing. It might be able to slow down a little bit if they had some extra fuel on board, but they'd have to have a different type of engine.
Everyday Astronaut off of YouTube says, well, it's plenty powerful enough. It would just destroy itself because of flow separation. I mean, I wouldn't know, so I have to take his word for that, honestly.
It's the general premise of, like, you look at any rocket when it stages, you've got those much smaller bells at sea level, and then you've got those much larger bells, engine bells in the vacuum of space, and that's there's a pressure change, there's a pressure differential between sea level and space, and so you actually change the size and shape of the bell to deal with that, deal with the expansion of the plume. And you can watch as any rocket lifts off, and you'll see on the launch pad, depending upon how the engineers decided to optimize the sea level engines, a lot of them you'll see the rocket fires kind of makes a V shape like this. You're actually under optimized, and then as it lifts off, it'll slowly, as the pressure reduces, you'll see that slowly become like perfectly straight up and down, and you're at perfect optimization right here, and that's usually a bit, a bit above sea level at that point. And then as it continues to go up, you're going to see the plume continue to expand, and that's your expansion, and you're actually losing efficiency as you're doing that.
Yep.
And so then you stage your vehicle for a couple reasons. You want to get rid of that dead weight, but you also want to use a vacuum optimized engine at that point. And again, this applies to every rocket. So you take that vacuum optimized engine, and now you've got it again. If you were able to see the fire in space, which you generally can't because there's nothing. Nothing for it to really burn against or to show against. If you're able to see it, it would basically be straight up and down again. Should be perfectly optimized.
Yeah. So just get an aerospike engine.
Just get an and so aerospike engines are actually interesting. I think that's a whole different topic. But yeah, so an aerospike engine is designed to automatically compensate for the pressure as it changes, and it will basically always be as optimized as it can be.
There's variable
it's not like
regions. It's much more. It's much easier for an aerospike to be optimized throughout the entire regime of flight from sea level to vacuum than you would with most other propulsion systems.
Yeah. So there you go.
Yeah.
So that's a bit of why, right? So if you're going to try to take a vacuum engine back into Earth, you're going to have expansion issues at that point.
Yeah, it would
else.
underexpand, and that's bad. So, because you'll have, in the flow separation, boom, wow, that turbo pump spun really fast.
Aside from that, though, there was a couple of other updates this week that SpaceX had. They tested out one of their new recovery ships they have called the Go Searcher ship, which has a landing platform on it, but unfortunately it's not for rockets. It's for a helicopter, actually. This is the recovery ship that's going to be recovering the crewed Dragon capsules after they return from the International Space Station with crew on board.
Put rockets on the helicopter.
Hey, there's an idea.
Rocket copter.
But yeah, you can see kind of on the deck they would have a crane that would lift the capsule onto the deck of the ship, and then the whole point of having a helicopter there is in the case of medical emergencies. They do have some facilities on the ship itself, but if there is a medical emergency, they need to be able to fly them out of there, the astronauts, as quickly as possible. So they tested out this recovery ship this week, and nice to see some of these images. Although it makes me wonder now if they could potentially do any sort of rocket landings on this. I don't know. Probably too small. Anyway, but other than that,
if you go back to that original image, there's a wheelhouse right next to the platform.
Yeah, and if you
Yeah, I
look
don't
really
think-
close, you can see a guy standing right
Yeah,
next to
I
it.
feel
That's
like
a
that
really
humans
small
on
pad.
board would want you to.
She's coming in hot, Captain.
I feel like that would not.
Like neat and all, but unless it's autonomous, like I wouldn't want to be that human.
yeah, no kidding.
No thanks. So.
I'm sure Elon could make it autonomous if it's not already.
I'm just saying.
So what is changing out? So going back to did you have more? I'm sorry.
Other than that, just something that I thought that was cool this week is that some of the commercial crew astronauts trained this week at SpaceX headquarters, Bob Behnken and Doug Hurley, they actually were training inside the actual SpaceX spacesuits, the real
Nice.
working ones, and I'm not sure which like module that are inside right now. I don't know if this is actually a flight model, one of the test articles, or if this is just a simulator. But yeah, I thought that was really interesting that all of these happenings have been going on at SpaceX just in the past week. So.
We're getting close to both SpaceX and Boeing doing crew flights in early 2019, right? So, yeah.
Yay.
So what does the stage 2 stuff mean for SpaceX or just in general? Like, are we going to
So yeah, I guess we kind of missed the whole point right there, was
Yeah.
that the whole reason of testing this was to test the technologies for their Big Falcon spaceship, which they want to use to land on Mars and eventually send people there and contaminate the planet.
Thanks for reminding me.
You're welcome.
But why do that? Because they're also working on, they made the announcements of BFR and BFS, Big Falcon rocket, Big Falcon spaceship. So why do this at all to Falcon?
So I think that just like how we were kind of saying, they need data and they need experience with lifting bodies and the technology that they want to use on the Big Falcon spaceship. Do they need that? I don't know. They might only be able to get that type of test from BFR, or rather BFS, with an actual BFR launch. So it makes sense to me as even if this is just a one-off test of here's a way that we can get data from this, but I would hope that this is an actual improvement and we might actually have Dragon, Falcon spaceships that, would be
that'd be cool.
just a six person or something.
Dragon Falcon spaceship hurts my head.
That does hurt, yeah. But if we had a Falcon spaceship that flew on the Falcon 9, I think that would be awesome because it would meet Elon's original goal of having the entire vehicle be reusable. The first stage, the second stage, and the capsule. So.
And I just kind of want to throw in too, because some people in the chat room were saying that testing a mini-BFS for atmospheric entry or hypersonic testing would not be needed because they're going to land propulsively. But that's at the end of the landing regime. You still have to deal with hypersonic entry in atmosphere, both at Earth and at Mars. So, and you have to get the data from that. And you're also going to be moving faster than a Falcon 9 Stage 1 as well.
Just a wee bit there.
Yeah, just a little bit.
Just a wee bit.
I think what does Stage 1 separate at? Like Mach 6, I want to say? Mach
You
6
can probably
or 7?
go back to one of the webcasts and
So
look at the
yeah,
meters.
probably something like that. And I mean, you're doing Mach 25 coming back in here at Earth. So
wait, hang on.
A little bit faster.
I do want to challenge you on using Mach speed. Like,
I don't know
Mach
what the
is the
Mach
speed
speed
of
is.
sound.
Fine,
So,
28,000 kilometers an hour.
Thank you. Now I know what you're talking
hair
about.
splitter.
I actually, legitimately though, like, how do you measure Mach when there's no air? What would the Mach speed of Stage 1 separation be? It would be 0, right?
Infinity.
Technically infinity.
Infinity,
so-
yeah, go the other way, yeah.
But
yeah,
I guess
so-
ground speed is what I'm trying to say here.
all right.
Like speed over ground.
Something else
So-
I just remembered is that SpaceX is contractually obligated to test a subscale version of their Merlin, or not the Merlin, the Raptor engine that is using methane, and they're doing that for the United States Air Force. So there's at least one mission that they would do on a Falcon 9 using a Raptor engine on the upper stage. So maybe they'll be combining both goals, test out the meet that obligation
Yeah.
of doing an actual flight of a subscale Raptor engine,
Yeah.
and while they're at it, get all the different data that they need for that type of reentry.
Yeah,
That's drawing some assumptions, though.
That's,
right?
that's definitely drawing some
absolutely.
assumptions. No, that's just a
That's-
thought that I had that, like,
Yeah, that's
maybe,
not, yeah.
because it sounds to me like this would probably be a one-off. Like, I don't see SpaceX, unless they are planning on recovering the upper stages of the Falcon 9 through some sort of plan like this, I only see them doing it maybe, like, 1 or 2 times, like if they needed to get additional data or the first one wasn't successful. So if it were me, why not meet that other obligation as well and fly the Raptor engine that they have to do at least once anyway? So one-off mission and a different one-off mission, why not combine them? That's my idea anyway.
Cool. Exciting announcements from SpaceX. Exciting to see what they're going to do. We're calling it Block 5.1? Block 5.
Sure,
5,
sure.
Block 5 full thrust.
Block 5 full. Yeah, Block 5 Mark II full thrust. Yeah.
Yeah. Yes.
Falcon 9 Block 5 upper thrust.
Upper thrust
Upper
version
thrust.
2.
The upper thrust.
Mark.
Upper thrust Elon tweet special.
And ETS.
Yes.
And
There we go.
ETS.
The
Yeah.
ETS,
So
the
we
Elon
got it.
tweet special. Oh man.
We are so on top of things.
We're going
at
to
this
take a
show.
quick break, and
So-
before we do, thank you to all of the citizens of tomorrow who
Yeah.
helped make this show go. Again, your contributions to the show are what make this possible week after week. Looking at our calendar, it looks like we're going to be able to do this show 50. That's 50 times this year. That's pretty incredible when you think about it's just a group of space geeks getting together and trying to do space geeky things in our free time, and it's because of everyone in there that we've been able to do this. And if you'd like to see improvements in the show, us do cool new things, expand the show beyond where it's at right now, head on over to patreon.com/TMRO, figure out how you can become a citizen of tomorrow, or if that doesn't work for you, also just subscribe on YouTube, hit that bell, that helps us a great deal. Tell people about the show, that helps us out as well.
Yeah.
And if you've got another talent, like if you like doing animations, you like doing doodles, I said cooking last week and I got mocked for that, but anything, you've got some talent somewhere, head on over to the community forums, let us know what you would like to do and how you would like to contribute. We would love to work with you on something, anything. We think it's a lot of fun. We're community driven. That's what we do. We're going to take a quick break. It's another calendar break because there's a obscene number of launches next week. And then when we come back, on-demand comments. Stay tuned. We'll be right back. LOS.
Look into her face, determination in her eyes. She won't give up or quit or fumble little fashion lines. Filled with awesome expectation. This girl's a fascination. And nothing in her way will keep her from her destination. 'Cause she's fire walking. She's fire walking. When it's hot, she keeps on moving. Through the heat, keeps on improving. Yeah, she's fire walking. She's fire walking to be free.
Acquisition signal. So Alex Physics in the break actually said, Ben forgot about S-Hail 2. I didn't. So,
Is that one still a maybe?
no, here's what happened. I eat my own dog food, and tomorrow is basically the sponsor of Launch Library, and we get all of our data out of Launch Library. When we built the calendar, which was late last night, S-Hail 2 on Launch Library was marked as to be determined in November, which means it didn't have a date attached to it. Now, if you go to another website such as Spaceflight Now, they did have a date attached to it. So because of that, and because I dog food this stuff, I did not include it in the calendar because Launch Library didn't say that it was a thing for this week. That's why it's not in the calendar. So yes, I should go over and actually say something on the Launch Library Discord channel. If you would like to help make sure that our launches are up to date, head on over to community.tmro.tv and I will get you in touch with everyone over at Launch Library because there are many ways you can help the show. Launch Library is one of them. It's actually one of those really cool things. If you don't know, it's a free API for developers to add launches into their apps. So when you get those apps that say, hey, look up historical flights, look up flights that are coming up, it is a great tool. We give it away to developers for free. So it is something to help allow developers get other people excited about space. It's just one of the fun little side projects for tomorrow. And we have librarians that keep that data up to date. So stuff and things if you'd like to help out with that. All right, Capcom, tell us a little bit about what we had going on last week.
Have you introduced
Last
Capcom?
week we
I
had
have not introduced Capcom.
The
Sorry,
one.
I'm
This is my
sorry.
beautiful
The
wife.
only.
It is my beautiful, lovely, wonderful, and talented wife, Cariann. We haven't. That is a throwback. That's a throwback for a long time. So you're welcome, Internet.
And all sorts of
She also a co-creator. She is.
No.
There's only one person other than myself that has been here longer, and that is actually, believe it or not, Colton. So I was here the first, Colton was second, and then Cariann was actually third. Starting with show number 2, 11, I suppose it'd be 10 years ago.
Yeah, because you needed me.
I-
So
oh
last
my
week
God,
we
I
talked
did.
about hashtag the Mars. I'm just going to
Still
keep
does.
moving because, seriously. Goodbye to Dawn and Kepler, a cavity from space, and Soyuz failure investigation, which was a really interesting, that was a really interesting show, I think, all the way around. First comment comes actually off of our community.tmro.tv. You've heard us mention it a couple of times so far, even on just this episode. It's a really great forum space. If you have questions, comments, concerns, complaints that are not addressed during these little sections of the shows, so many complaints, mostly about Ben.
Almost all.
That's the place to really air your dirty laundry, I suppose. And yes, Serial Killer and YouTube is asking, is Colton here today? Colton is always here. Don't even worry about that. So again, first comment comes from community.tmr.tv TV from Deborinsky.
Borinsky.
Yep.
Deborinsky.
I'm going to make you say
Sounds
all
good.
those now.
Sounds good.
It says, regarding U.S. astronauts utilizing Soyuz after commercial crew comes online, NASA has an agreement with Roscosmos to essentially trade seats. This means that even if U.S. astronauts fly on the Soyuz, the U.S. will not be purchasing those seats, just trading Roscosmos a seat for their use on commercial crew. This does mean a reduction in dollars, I suppose, to Roscosmos, and that reduction could have a negative impact on Soyuz reliability. I was not aware of this personally. Secondly, I don't understand it.
So basically, go ahead.
So that is true, but the way that I kind of look at it is NASA would still be paying for seats because who's buying the seats on the commercial crew? NASA is, and they would be giving one of those seats. I'm sorry, I knocked over your cup again. They'd be giving one of those seats.
That's a 12. We
to the
determined
Russians
earlier. That's a $1,200 cup.
Should I throw mine just to even it out over
Please. So yeah, they would be giving one of those seats that NASA is purchasing on commercial crew to the Russians in exchange for a Soyuz seat. So, I mean, we're still paying for it. It's not
Well,
just
wait,
it's
so-
not just an even
I know,
trade.
but I don't understand though. So what you're telling me then is that there are NASA astronauts that are going to be flying on Soyuz, but then eventually, like, instead of paying them, then there's going to be Russian astronauts flying on commercial crew?
Yeah, just like Space Shuttle, right? And that's one of the things that we kind of didn't really bring up in the last show, or even really consider, is that, you know, during the Space Shuttle era, it's not like it was all just American astronauts on the Space Shuttle. It was a multinational crew, including Russians. And so we can probably expect the same, well, we will expect the same thing with commercial crew. We'll be doing seat swapping between all of these different spacecraft, you know.
And the original plan, way back in the day during the Constellation program, is we were going to have the Orion capsule.
Pronounced that wrong.
Constellation program?
Cancellation.
Cancellation
Cancellation.
program. Oh, excuse me. We were going to have the Orion capsule go and have regular flights to the International Space Station. That was going to be our new crew transportation system before commercial crew. And this deal was made like a long time ago that once Orion got flying, that we would continue to trade seats. And then with the Russians, as soon as they got their next crewed spacecraft, which is now called Federatsia, as soon as that was up running, we'd be doing the same thing. So we've just adjusted that plan once commercial crew became a thing to, okay, we'll trade you seats on commercial crew that we'll be paying for.
I guess okay, so I don't understand why, but Zaphan off of YouTube says
Zaphan!
paying $20 million per seat rather than $80 million.
Yeah, I think fundamentally that's the question: is are we still going to be paying $80 million, or are we going to be paying $20 million? And we're not going to actually buy a seat on a Russian
I don't know.
craft, and we're just paying $20 million for commercial crew, and then just swapping around the chairs as to who goes where.
Well, I mean, that is one of the questions, but the other question, quite legitimately, is why? No offense. If Russia's got their own taxi to space, why aren't they just taking that?
They will.
And if America's has their own taxi to space, why aren't they only just taking that?
There's no need to only take, because it's an international cooperation. It's, you know, everyone being happy with everything else.
And then Seki says, so like taikonauts are out then? No room for Chinese at NASA.
Oh, yeah, that's actually a thing. That's not really a
Yeah,
NASA
that's
thing.
a
That's a
political
U.S.
thing, though.
government political thing, and that's not untrue. The U.S. politics don't really allow for. Like China wants to be part of the International Space Station.
Yep.
Oh yeah, Russia wants them to be part of the international.
Yeah,
Space Station.
the U.S. is like.
ESA does. Yeah, it's only the United States. Everyone else wants China to be a partner except for the United States.
Yeah, and you'll notice everyone else is working with China.
Yes, they
the
are.
United States is not.
Yes, they are.
But to your point, you have these crews that are going up not based on what country they're from, but based on what that crew needs to do. And maybe a Russian is part of that crew, so you wouldn't send up both a Crew Dragon 2 and then concurrently also a Soyuz, so you could get all those crew members up to the station at the same time. You'd be like, no, that doesn't make any sense. I need the Russian, the American, and the I don't know, whatever.
Either European,
Canadian,
or
sure, whatever.
Japanese.
Right, to all go up as this one unified crew. We're going to send them on Crew Dragon 2, or we're going to say no, we're going to send all of them up on Soyuz. They're going to go up as a cohesive group on whatever vehicle makes sense, not on whatever vehicle is in their country that they happen to be born in.
Dutta says it's an Uber carpool. I mean, sure, I guess so. I guess I just.
Do you? They should add. That would be amazing. Add that into
ride
Uber. Be
share.
like, yeah, ride share and a
Uber
rocket. Be like
rocket.
20 million.
I mean, you oftentimes have more than one mission crew on the International Space Station at a time.
Yeah, but
There's
The
It's
two or
transition.
three overlap.
Yeah.
yeah, they overlap.
Yeah, so it's like you've got the existing crew, and then you've got the crew that's taking over, and so they're only there at the same time for that window.
Yeah, but
And-
sometimes there are crew members. Are there not mission members or crew members that go from one mission to the next mission?
Yes.
Right.
Yeah, they stay on,
The
so they'll go from
expeditions, yeah.
expedition like 24 to 25.
Yeah.
So, yeah.
But regardless of their nationality, they're going to send them up on whatever vehicle happens to be handy, not on, just because you're Russian, you can only fly Soyuz. So if I need to get my crew up, my expedition, whatever next number is, I'm not going to send half of them on Dragon and half of them on Soyuz because that's their nationality. I'm going to send them all on Dragon or all on Dream...
Starliner.
I don't think they can make it on a Dreamliner. I don't think it has quite the speed necessary.
Yeah, I mean, it's a little higher than most
Little
other
higher than
planes,
what a
but,
Dreamliner can go.
Yeah.
I'll send them all on Starliner. I'll send them all on Dreamliner. No, Starliner.
So yeah, a crew of three would go up to the space station. There's already a crew of three that's been up there for roughly 3 months. And then they'll be together in the same expedition. That crew of 6, sometimes 5, will be part of that same expedition. Let's say like Expedition 37.
Sure.
And then when the crew that had already been there for 3 months, after they've all been together for 6 months, or once that first crew gets to their mark, whenever they're supposed to go home, when they leave, then the crew that's still up there becomes the next expedition. So it would be Expedition 38.
Okay.
And then the next crew that would come up would be joining their expedition, and it keeps leapfrogging like that. It's confusing.
I don't know where I'm
It's
getting
confusing.
lost in this. Let me break it down a little bit further, I suppose.
Please.
Soyuz has how many seats?
3.
Cool. Crew Dragon has how many seats?
Potentially 7, but I guess 4 now?
Yeah, I've heard 4 is what they're going to use as the standard.
Starliner
yeah,
has
so-
how many seats?
Supposedly 6, but also maybe 4.
Okay, I'm
Yeah.
done. Next comment. I feel like I can't anymore.
Fair enough.
I don't know where I'm
Yeah.
getting
No,
lost, but
I understand.
thank you.
I'm confused too right
Thank
now.
you for
so
hearing
don't
me.
worry.
That's all I want.
Right there with you.
Next comment comes off of YouTube from Barry Hayworth. Regarding the new format of these episodes, I think that it is in need of fighting up. That must be a phrase I'm just not familiar with. The length of episodes
I think
in general,
tightening up.
okay, is heading up, and the amount of information is not increasing to match. I've been enjoying the 1 hour length format, but length is heading up to the signal to noise ratio is dropping.
Yeah. So we're playing with the format, right? We're trying to get it right, and you're not wrong. The noise went up. The noise went up too high. There will be more added noise in this new format because it's going to be we're just going to sit here, we're going to nerd out, we're going to have fun, or geek out, whichever term you prefer, right?
Yeah.
I mean, it's just more of a dynamic conversation, I think. And yeah, not everything's going to be perfectly relevant. We're going to talk a little bit about movies that are hilarious. We're going to laugh, we're going to joke, we're going to have fun with it. And I think that's okay. Like, if you want just a proper news format show, there are many places where you can get that online. You totally should. Like, Space News is great. SpaceNews.com, SpaceflightNow.com is great. NASA Spaceflight is freaking incredible. Like, the wealth of information there is obscene. It's like drinking from a fire hose of space information.
Yeah.
No, really, it's just impressive. Just hit their L2 forms. It's great. If you
Holy
haven't
moly,
already-
yeah, L2 is so awesome.
It's
I love
awesome.
it.
Highly recommended.
Yeah.
So there are all these really great sites that are going to get you news faster than we're going to be able to get it to. What we're going to do is we're going to break it into conversation and talk about things and enjoy it and have fun with you and build a community around it, because that's what we want to. That's what we want to be. Is we want to be a community.
Psyche says, good luck interacting with those other shows.
Yeah, because they're not in video format.
Well, no, but
There is no other space news like show.
It is,
But that's the thing.
funny
We
comment.
also interact, right?
Yeah.
And we talk back and forth. So I do hear you. You're not wrong. The noise, the signal to noise, did get disproportionately
We're working on
towards
it.
noise. We're bringing that. I think this show went better, right? We're not at that weird 2-hour mark, but yeah, I think I'm going to target 60 to 90 minutes per show. That feels like a good length. And yeah, we're going to keep playing with it. And as I said, I think in pre-show, and I haven't said it in the actual show itself, guests are not gone forever. We're at the end of the year. It's always exceedingly difficult to get guests at the end of the year because we have
Yeah.
this holiday season.
Holidays, one right
So
after the other.
We're still going to try to bring guests on this year if we can schedule anything in. But in this new format, what I'd like to try to do, and I do not know that this will work. This may epically fail, but I like to use Tori Bruno as an example, because Tori Bruno is just a hardcore space nerd. He has it. It's in his blood. It's part of who he is, right?
Yes.
He loves this stuff. He loves all of it, whether it's United Launch Alliance or not. He just apparently, I don't want to speak for him, but from an outsider looking in, he appears to love all of it. Wouldn't it be awesome, instead of just bringing Tori on to talk ULA, wouldn't it be awesome to have Tori Bruno sitting here on set, just talking about the entire thing, all of the news that we covered? Wouldn't you love his opinion on everything? That's what I think we should do. I'd love to have our guests in to actually talk through the entire news section and talk to them about what they're an expert in whatever they're doing.
Yep.
And just as if you had them joining you at your house and you all just wanted to space geek out, that's what you would do. That's what this show should be. It's just a bunch of people space geeking out. So that's what I'm trying to get towards. You're seeing these tweaks to the format. Hopefully we're making it better, not making it worse. But I think foundationally, this new format does make a lot of sense. So guests aren't gone. They're coming back. It's going to be awesome. We're going to screw up royally sometime in the future. Like, it's going to be an awkward, horrible show that will come down the pipeline. We'll learn from it and we'll move on. All right, there you go.
Awesome. Last comment comes off of YouTube from one William Warren. Has any significant research been done on the effects of 1/3 normal gravity on the human body over prolonged exposure? If living for an extended period in 1/3 normal gravity causes significant serious damage to the human body, then Mars and the Moon are essentially worthless for human colonization. Before we spend tons of money trying to colonize Mars or the Moon, we should know the answer to this.
Yep.
Yeah, I agree.
And no, there hasn't been a study.
Nope. And we don't know. Fundamentally, we built the centrifuge for the International Space Station, and it's sitting in Japan right now?
In a parking lot.
In a parking lot, yep.
Yep.
And it will never fly.
Near Tsukuba Space Center.
Yep, it will never fly, and that makes me sad. And we absolutely, you're not wrong. We need to run those tests. We need to understand what the long-term, like, we know what 1G does to the body. We have a few years of study on that. 1 or 2, right?
Yeah.
We know what microgravity does to the body. We have actually only a few years of study on that, not nearly as much as 1G. But those things in between, no idea.
Yep.
No idea. And you're absolutely right. We should absolutely study that. And it would be good to do it before we go to the Moon and onto Mars. Although I don't think that we should just stop our lunar ambitions or Martian ambitions because we don't know that answer yet, because I'm not sure we're going to get that answer. And what better place to get the answer than in the actual environment
Yeah,
itself.
I'm also pretty sure that initially with at least our lunar ambitions, which seem to be the ones that are going to be happening first, we're not going to be staying really long enough initially to have really negative health, like hardcore negative health effects. And also, we could do like what was done in the early space programs, can a human actually survive a flight to space? Okay, they can. Can a human survive multiple days in space? Okay. Can a human survive 2 weeks in space? Okay. Can you do 30 days, 60 days, 90 days, 180 days, 365 days? You can progressively add on to that. There's nothing that says that the first medical study that we do of a human in lowered gravity has to run for the duration that human will be spending in that lowered gravity. So.
And our latest long duration stay on the surface of the moon was what, a couple of days?
Yeah, 3 days.
Yeah.
So yeah.
So yeah,
Who
we need
knows?
to study that. And aside from NASA, that's what the rest of the international community wants to do. ESA with their moon village, China with their lunar base that they want to do, and they're cooperating together. I mean, Samantha Cristoforetti is in China right now training to go to the Chinese space station. So we're going to see China and ESA cooperating on a lot of human spaceflight projects. And honestly, if we don't cooperate with China because they're working very closely with Russia, working on engine technology to actually land on the surface and send humans and large amounts of payload to set up structures and things like that. They're working on that right now, and if we don't participate, we're going to be left behind.
I go back and forth on that, but I think that's a conversation for another time because
Yeah.
I don't disagree that leaving countries out seems weird, but at the same time, commercial crews seems to be doing incredible things at a rate that seems to be faster than countries. So that is an interesting conversation that we will put a pin into because this show will go for another hour and a half just on that one topic.
Seriously.
All right, I do want to thank all of the patrons and citizens of tomorrow who helped to make this specific episode happen. These people contribute. The slates that you're going to see here contribute anywhere from $1 to the episode all the way up to $10. And once again, these people help make this show go week after week. We do have, we have the studio space. A space station's expensive, man. Like keeping this
It
thing
ain't cheap,
keeping
let me
this
tell
thing
you.
in orbit, it's really expensive. But we have to pay cameras, we have people that we need to pay, there's bandwidth bills, there's all of the stuff that goes into the show. And we essentially all do this for the love of it. It's not something that we make any money on, really. It's because we think it's important and we absolutely love doing it. And everyone in these lists also obviously loves it as well. So thank you to everyone who helped make this go. Also, if you can't contribute financially, it's totally fine. I understand. Been there, done that. There are other ways that you can contribute. You can contribute just by simply subscribing to our YouTube channel, hitting the bell, telling people about it, and once again, going over to that community forum and being like, hey, love the show. I can help in X, Y, or Z way. And, there are whatever you're passionate about, just let us know. I'm sure there's something that we can do. Programmers, animators, people who can make music, people who can writing stories, right? Even just having ideas as to what we can do, all useful stuff. So thank you to everyone who helped makes the show go. All right, that's our show for this week. Thank you so much for joining us. After Dark, up next.